Okay, so we're going to be talking today about prime factorization. Now, you guys, prime factorization is absolutely vital for if you have any dream of being proficient with any operation that deals with fractions. Okay? So this is something that you're going to have to learn. You're going to have to practice it. Okay? Now, every class I've ever taught, prime factorization is a skill that the students get really, really good at. Okay? Because we do it so much. Now, again, we're going to start talking about vocabulary. The word goes in the first box. The definition goes in the second box, right? Talk about 3-column notes. Write prime numbers. Now, the definition of a prime number are counting numbers that can be divided by only two numbers, one and themselves. It can also be described as a counting number with exactly two factors, one and itself. So when you're talking about a prime number, it can only be divided, only divisible by one and itself. Okay. So with our divisibility rules, what we learned yesterday is that it would be a no on everything, and it's not 49, 77, or 91. So it has exactly two factors. Now, for your example, okay, for the example, just write a prime number. 7 is prime. Because the only way I can make 7 is 1 times 7 equals 7. And the only thing I can do with 7 with division is divide it by 7, or I can divide it by 1. Okay. Bless you. Okay, the next one is composite numbers. Now, once again, we learned yesterday what a composite number was, and a composite number has more than two factors. All counting numbers that are not prime numbers except for the number 1. All right, they have more than two factors. They have more than two factors. Okay, so the word goes in the first box. The definition goes into the second box. For your example, you could write 6, because I could say 1 times 6. I could also say 2 times 3. Okay, so this one has 4 factors. Get it right fast.
No.
The final word is prime factorization. Okay. Now, prime factorization is where a composite number is written as a product of prime factors. Product means the answer to a multiplication question. So you're going to rewrite a number using multiplication of only prime numbers to come to that number. Okay? So for example, if I take the number 8, I can rewrite that as 2 times 2 times 2. 2 is prime. It has exactly two factors. And 2 times 2 times 2 is 8. Okay? So I took a number and I rewrote it using multiplication of only prime numbers. Now, I will give you a few minutes to catch up to that, and then I want you to draw a line under prime factorization, and I want you to be ready to start writing the steps for prime composite numbers. Okay. All right, here we go. So now we're going to talk about the steps for writing a number as a product of prime factors. Now, the first step is you're going to use the rules of divisibility that I taught you the last couple days to determine a number's first two factors. So I'm going to put a number on the board and we are going to find this number as a product of prime factors. Okay, so we're going to use the number 60. So when looking at the number 60, step one is very simple. I'm going to take my divisibility rules for 2, 5, 10, 3, and 9, and I'm going to determine yeses and nos. Now, I see that 60, because the ones digit is a 0, is a yes on 2, yes on 5, yes on 10. 6 plus 0 equals 6, so it's going to be a yes on 3 and a no on 9. Now, when I'm talking about a product of prime factors, I now have a starting point. I know that one of 60's factors is 2, one of them is 5, one of them is 10, and one of them is 3. Now, step number 2 is after you've determined the first two factors. So for 60, I'm going to use 10 as one, and then I'm going to use division to find the other one. So 60 divided by 10 is 6, or 10 times 6 equals 60. So step number 2 then, it says ask yourself, are the factors prime or composite? Now, because both numbers are even, I know that my numbers are composite because there's only one even prime number, and that's the number 2. So 10 is composite and 6 is composite. So after you have determined, so you've got the first two factors for your number, you determine if the factors are prime or composite. The next step is going to be, if the number is prime, circle it. I don't have any prime numbers here. Now, if I would have gone like this, if I would have gone that 60 is 2 times 30, then 2 would be prime, and I would circle my prime number. Okay? But the important part to remember that if you get the first two factors, and one of them happens to be prime, or both of them are prime, you're going to circle them. Then I'm going to go to step number 4. If the number is composite, you're just going to repeat the steps. You're going to identify 2. So we said 60, we said is 10 times 6. So then I'm going to take my two composite numbers and break it down further. So what two numbers could I use to multiply together to get 10? Well, I know it's divisible by 2 and it's divisible by 5 because it ends in a 0. So it's 2 times 5 is 10. Now, is 2 prime or composite? Well, 2 is prime. So I'm going to circle the 2. Is 5 prime or composite? It's prime, so I'm going to circle it. Now I'm going to break 6 down. 6 is even, so I know it's divisible by 2. So 2 times what is 6? Well, I know 2 times 3 is. And I know 2 is prime, and I know 3 is prime. Okay, so that is the 4th step. Okay, now, the 5th step is I continue till all the numbers are circled. So notice, I started with 60, I broke it down into 2 trees, 2 branches, and I took 10 and broke it into 2 parts, and then 6 into 2 parts, but there's no parts left. So I have continued until every number is circled. I no longer have any branches that need to be broken down further. So once I have circled everything, the circled numbers are my final answer. So 60, written as a product of prime factors, is 2 times 2 times 3 times 5. So 2 times 2 times 3 times 5. Okay? Now, I will give you just a few minutes to get caught up, so you guys finish your notes quickly. I am going to write a number on the whiteboard, or smartboard, and you are going to copy it, and you're going to do the steps with me this first time. So I am going to do it. You are going to follow along as I do it. So the number I'm going to look at, you guys, is I'm going to look at the number 54. So on your whiteboards, everybody, write the number 54. Now the first thing I'm going to do is use divisibility. So I have 2, 5, 10, I have 3, and I have 9. Okay, so the ones digit is even, so it's a yes, and then it's a no, and it's a no. At this point, you should understand the rules of divisibility on how I got those. Now, if I take 5 plus 4, that's going to equal 9. So it's a yes and a yes. So I now have a starting point. Now, if I take this and I say I'm going to use 9, 9 times something is equal to 54. If you know your 9s, then you know it's 9 times 6. So now I'm going to ask myself, is 9 prime or composite? Well, it's composite, right? Because I know I can take 9 and I can break it down into 3 times 3. Then I'm going to ask myself, is 3 prime or composite? Well, I know 3 is a composite number because the first 5 prime numbers are 2, 3, 5, 7, 11, right? Now I'm going to look at the number 6, and I know number 6 is composite because it is even.
What 2 and 3?
So I know I can break 6 down into 2 times 3. 2 is prime, 3 is prime. Now look it. I took 54 and I broke it into 2 branches. And then I took 9 and broke it into 2 branches, and I took 6 and broke it into 2 branches. But the branches on 9 both were circled. The branches on 6 were both circled. So now I have my answer. So I'm going to write 54 equals 2 times 3 times 3 times 3.
Oh. 2, 3.
Okay? Okay. Please erase your boards. Okay. Everybody write 91. 91. Okay, on the side of your boards, I want you to write 2, 5, 10, 3, 9. Now the ones digit is odd. So that means it's a no on 2, and then it's a no on 5, and a no on 10. So no, no, no. Now 9 plus 1 equals 10, and then 1 plus 0 equals 1. So it's a no, and it's a no. Now we learned yesterday that if it's a no on everything, it is a prime number except for 3 exceptions. What are my 3 exceptions?
49, 91.
Aha, and this one is 91. So because this is one of my exceptions, what number is a factor for 91?
8 times, oh, wait, 9. 7 times.
Means it's divisible by 7, right?
7 times 13.
7 times 13.
Jeez.
7 is prime, 13 is prime. Circle 7 and 13. So 91 equals 7 times 13.
What?
Erase your boards. Okay, here we go. 435.
By yourself?
Write it. Okay. This is a 5, so it's a no, a yes, and a no. 4 plus 3 plus 5, that's 7 plus 5, which makes 12. So 12 is a 1 plus a 2, which makes 3. So it's a yes and a no. Okay? Now, here, because it's a yes on 5, I'm going to use 5 as my first factor. I'm going to use 5 as my first factor. to figure out my second factor, I'm going to actually have to do the division. So 5 will go into 48 times. That's 40. 3 left over. Bring down my 5. That's going to be 7, which is 35. 0 left over. So it's 5 times 87 are my two first factors. 5 times 87. Now, I see that 5 is a prime number, so I'm going to circle. Yes. Certainly. Hey, Jonathan. Jonathan, your dad's going to be a little late. Okay, 87. Everybody now do divisibility rules for 87. That's a 7, so it's a no, a no, a no. 8 plus 7 equals 15, right? 1 plus 5 equals 6, so it's a yes and a no. So I can divide this, I can multiply 3 by something. Use division to find the other number. So I'm going to take 87, and I'm going to divide it by 3. So that's going to be 2, which is 6. 2 left over. Bring down my 7. It's going to be 9, which is 27. 0 left over, so it's 29. Now I know 3 is prime because it's 2, 3, 5, 7, 11. Guys, 29 is a prime or composite. Divisibility rules. Is it divisible by 2? 5? 10. What's 2 plus 9? What's 1 plus 1? Is it divisible by 3? And is it divisible by 9? So it's a no on everything. Is it 40, 49, 77, or 91? Then it is prime. So 435 rewritten as a product of prime factors is 3 times 5 times 29. We're going to have to come back to this tomorrow. So please put this away. Please take out your agendas quickly and quietly.